Hi and welcome. Today I'm going to show you how you can quickly read in and edit experimental data that you have so the data becomes suitable for material model calibration. Typically, experimental data that you get from a test machine is not really in the format that's needed for calibration, and today I'm going to show you how you can do that very quickly. So here's an experimental data file that I'm going to demo this on. It has 3 columns: time, engineering strain, and engineering stress. And I'm going to now show you how you can work with this data and make it suitable. And you can always, of course, do this using Excel or MATLAB or some other language like that. But as I will demo, this is very easy to do using MCalibration. And the procedure is more intuitive, I think, and quicker if you use the tools that come with MCalibration. So I have a window of MCalibration here. I'm going to maximize it, and I'm going to go to the Edit Data tab, and I'm going to load in this data file in here. So here's the file I want to work on. It's a CSV file, and I was reading this file here. We see that it has 12,524 rows of data, and here's the raw data plotted as column 1 versus column 2 in this case. The first thing I'll do when I work with data is to specify what the different columns are. So the software actually uses that information to make the cleanup better and faster. So this is time, engineering strain, and engineering stress. So I go to set column name, and there's a predefined version here. So I can just apply that to all 3 columns at once. Otherwise, you would pick one column at a time and just set the name of that column. So we've done that now. Here's time, strain, and stress. Before we look too much further, we obviously want to see what the data looks like. So time versus strain, it looks like this starts about 0, 0. It's a compression and then a rapid reset of sorts here, and then the test goes on. So what happened here is that this initial portion of this file actually is not valid. That's a preload or some weirdness that happened during the test. We don't want to use that for calibration purposes. So what we want to do is get rid of some of the points, data points that are not valid. So I'm going to click in the graph here on the first data point that I want to use, and any data points before that I want to get rid of. So I'm going to select the row before that. I'm going to type Control-Shift up arrow, select all the data above, and I can just press the delete key on my keyboard, and that deletes all of that data that was before that data point. So that makes the data look a little better. It has more valid and relevant information. The next thing we'll do is that we need to work hard now to set the time to be 0, the strain to be 0, and the stress to be 0 at the beginning of the test. If you have a test specimen that you want to test, obviously, if there is no strain on it, there shouldn't be any stress on it. And for calibration purposes, that is also true. At the start of the calibration, it has to be 0 strain and 0 stress and 0 time. So we can just set the time to be 0 by selecting any value in the time column and click Make Column 0. Similarly, we can set the strain column to become 0 in the same way. We could do that for stress as well, but that's usually not the best idea because the test machine is often put into place and the actual value of stress here is actually probably true what the force and the stress was at that point. So we don't want to make that 0, shift that away. Instead, we want to be more careful about that. Instead, though, before we do that, let's do a few other cleanups here. This is a uniaxial compression test, and we see that the strain is negative and the stress tends to be positive in this file, and that's clearly not the case. In MCalibration, just like in most sort of real calculations you perform, if you have compression, the stress and strain is negative, and if it's tension, the stress and strain is positive. Same thing needs to be applied here. So the strain is okay, but the stress values needs to be modified to be compressive. So I can do that by selecting this column, and I go to column operations, and I say multiply add cells, and multiply all the selected cells by -1. That will simply just change the sign of those values. So here are now the corrected data points, if you want to call them that. It's a negative stress, negative strain. So that's what it's supposed to be looking like. We see that the data points are kind of spaced out in a funny way. There's very large gaps between some of these data points, and some data points are very close together. That's not optimal for a calculation using MCalibration, because when you do the material calibration, it calculates the error between the predicted data points and the experimental data points, and it sort of naturally will bias the regions where the data points are located. So there, in this case, we have many more data points in the relaxation portions, so that's not really what we want typically. So I will actually resample these data points so that they are more evenly spaced out. And one way to do that is just to click on this number of rows button, and it will change the number of rows of data. And by doing that, it will actually resample them for us in an even spaced out way. So I'm going to click on that. Instead of 9,000 data points, are going to be maybe 1,000 is good enough to represent this data set. So clicking on that, we see it looks like there's more data points now, but it really isn't. There's 10 times almost less data points, but they're evenly spaced out. That's really what we want to see. And now we're starting to look like we could start using this data, but there's a few more things we want to do. If you look at the origin here, the stress is not 0, but another more important issue perhaps is that this initial slope of the stress strain curve here has a value or a slope like this, and then further along here it becomes higher. And that is not physical. That's not how these materials behave. There's really no material that does that at these small strains. If anything, it should be bent over. The stress strain curve should slope over that way. The tangent stiffness usually goes down with strain and not up at these strain levels. So this is an indication of an experimental error. The specimen probably wasn't fully parallel, the top and bottom surfaces. So we need to fix that. And one way to fix that is to do something called a towing compensation. I'm going to get rid of the data points here that I believe are incorrect. I'm going to click on this data point here. Let's try it again. Maybe this data point, or maybe if this one would be good. I think as I'm looking at this, I actually think we're going to get rid of a large number of data points, because I think the slope here looks different than what it is here, and I don't like that. I think that's an incorrect experimental data set. So I'm going to delete these. And the problem now, of course, now our stress strain curve starts over here. That's not how the real material should be. It should go backwards with whatever slope we have between these points all the way back until it hits this point, and that should be the start of the test. And we can achieve that very quickly here by telling MCalibration to use a towing compensation, and that's something that is easy to do. It's just clicking on 0 point, and there add 0 point to towing compensate. I'm going to do the towing compensate option here. It added this data point here, and it shifted the curves properly now. So it looks like we have a nice homogeneous slope here, as we would expect it to be. The problem, of course, is that there is a huge step size between the first and the second data point. So again, we can fix this by changing the number of rows of data. I'm going to make it, say, 900 at this point, and just to fill out this data a little bit more accurately in this case. Many cases you may want to smooth the data. If you think the data has noise in it and you don't like that, you can select smooth the stress and clicking on this button here. We don't need to do it because the data looks actually quite smooth in this case, so we don't need to deal with that. So instead, once we have data here that we cleaned up that we want to work with, I can click on data, save data to new file, update the load case with the new data. Yes, and here it is, and here's our new load case in here that has this new information that we have in mind. So that's how you can quickly clean up an experimental data file using the cleanup tools in MCalibration. There are many more options here that you can play around with by just clicking on these and reading on them. And if you have any questions on how any of this works, you can ask them below.